Hello, Aida.
Yes?
Yeah, this is Mohamad.
Yeah.
I think I want to study together with you on calculus. Do you want to study with me?
Yeah.
Yeah?
Yeah.
Okay. Ni, guitar.
Yes.
Really? Okay, let's go.
I'll be there.
Where's Aida?
Me.
Aida! Tidak dah.
Mood. Me.
Yeah! Let's go.
Let's go.
Aida,
Yeah?
can you help me? I missed sales class last week.
Oh, no.
I don't understand anything. Can you help me actually?
I would like to teach you, but I having trouble understanding the topic.
Really?
Yeah.
What should we do?
Should we go Mazhan?
That's a good idea. I got Koyana.
Yeah.
Yeah, that's a good idea. Let's go.
Slay.
First time.
Oh, alright. Okay. Hey Anna.
Oh, hey.
Mohamad and Aida just called me to help them to study. Should we go together to help them?
Yeah, sure. Why not?
Alright.
Let's go.
Hey!
Hi.
Oh my god! What are you guys?
We almost died.
So, me, Aida,
Yeah.
what is the problem actually?
Yeah, what can we do to help you guys?
So we've been trying to do this question on applications of differentiation, but we can't seem to understand.
Yes, I really want to teach him, but I couldn't understand the topic really well.
This question. I think I did it last week, right?
Yeah, that's right. We can teach you actually.
Really?
We don't really like that.
Let's see the question.
So, MAT183 Calculus 1. So this topic is about differentiation, which are the maximum and the minimum values. So here I'm going to introduce you about the topic, concept and the definition. So what is differentiation actually? Differentiation is a process of finding a function that outputs the rate of change of one variable with respect to another variable. So derivative of a function y equals to fx of a variable x is a measure of the rate which the value y of the function changes with respect to the change of the variable x. Derivative of fx with respect to x. So here I'm going to provide you a few examples. Fx equals to 6x cubed minus 9x plus 4. To differentiate from the fx is going to be f prime x equals to 6 times 3 x 3 plus 3 minus 1 minus 9 times 1 x 1 minus 1. So here is a constant. So if it's constant, we need to ignore it. So it's going to be 18x squared minus 9. So another example, which is y equals to 36x cubed plus 4x minus 7. So again, to differentiate the y is going to be dy over dx equals to 36 times 3 x 3 minus 1 plus 4 1, so x 1 minus 1. So here again, this is a constant, so if it's constant we need to ignore it. So it's gonna be 108 x squared plus 4. See, it's easy. So that is the basic of differentiation. So to find the maximum and minimum problems, the function together with its domain will determine which technique is appropriate to use in finding a maximum or minimum value. So there are several ways to find the maximum and minimum value, which is the first one. The first method is extreme value theorem. Next, the first derivative test, and lastly, second derivative test. So the process of finding maximum or minimum values is also called optimization. So I'm going to explain to you what is the objectives of maximum and minimum problems. Why we need to do this. So first, to identify critical points for a two-variable function. The second one is to identify boundary points to determine absolute maximum and minimum values.
So next for the problem statement, a closed box has a volume of 15,000 cm power of 3. The length of the box is 3 times of its width. Find dimension of the box that will minimize the surface area of the box. Hence, find the minimum surface area. For the solution, for the step 1, you need to draw an illustration of the surface of the box, of the closed box, which is you need to find the volume of closed box first, which is using this formula. Volume equals to length times width times height, which is gonna be volume equals to 15,000 and length 3 times of its width, while width is x, height is h. You need to state it that h equal to 15,000 per 3x power of 2. And the surface area of closed box is s equal to 2 times length times width plus 2 times length times height plus 2 times width times height. And you need to put the L and put the 3x, x and h back to the equation. And you need to solve it, which is going to be 6x power of 2 plus 6xh plus 2xh. And you need to put the h back to the equation and you need to solve it, which is going to be 6x power of 2 plus 40,000 per x. And then you need to find the dimension of closed box, which is dx per dx equal to 12x per minus 40,000 per x power of 2. And you need to find the critical point, which is you're going to let dx per dx equal to 0. And dx per dx is equal to 12x minus 40,000 per x power of 2 equals to 0. And you need to clarify it to be 12x power of 3 minus 40,000. And you need to let x equal to 14.94 cm. That's the critical point. And next, you need to determine whether the critical point is maximum or minimum using this formula, which is d power of 2 s per dx power of 2 equals to 18,000 per x power of 3 plus 12. And you need to clarify it to be 36. That's the minimum point of critical value. And you need to put the x into the equation of height, which is gonna be 22.40 cm. So the answer or length of the box is 44.82 cm and width of the box is 14.94 centimeter and height of the box is 22.40 centimeter. And for the last step, you need to find the minimum surface area, which is if x equal to 14.94 centimeter and the surface area is 6x power of 2 minus 40,000 per x, you just need to put the x back into the equation of the surface. And you need to clarify it, which is going to be 4016.60 centimeter power of 2.
Oh, I see now. We can conclude that minimum and maximum problems can be solved using second derivative method. Integral calculus or integration is basically joining the small pieces together to find out the total.
Oh, it's really like that.
Yeah, I think I could score the next assessment later on.
Yeah, it's really simple as that.
Yeah, and that's good that you can understand.
Yay. Oh my god, it's late now. You haven't eaten anything yet.
Oh, it gives me an idea. How about I treat you guys to dinner? How does that sound?
Yeah.
That sounds great.
Okay, let's go. Nampak Aida?
2, 3.
Aida!
Hey Yana. Oh yeah.
We almost done. Kau yang tu sebut kat mas macam mana? Mati aku.
Tak apa, dia je.
Ayam.
Ayam.
Record ke? Behind the scene.
Behind the scene, yes. Behind the scene.
BTS.
BTS, BTS.
BTS.
Oh, BTS. Okay.
Yeah, it's really simple as that.
Yeah.
Oh my god, it's late now. We can't make it yet.
Yeah, I know. What about this? I lanja you guys.